Hi, everybody. My name is Woody Walton. I'm a principal solutions architect here at Elastic. Today is the topic of DevSecOps, where Elastic fits in the picture, and then how my particular slice of the world is the DoD space. Obviously, the concepts are relevant to any large scale kind of deployment platforms that folks want to use. Right now, we've got a fairly small audience here. Can I maybe poll the audience and see what kind of experience folks have with DevSecOps, with Kubernetes in general, what your interest is in this topic? Anybody want to speak up at all? I know Brian is the only name I recognize so far. And I know Kathy's from Virginia, so I might pick on her too. But
yeah, I have minimal experience, but I'm in the Engineer One training stuff on your training portal, so I'm working through that. So I thought this would be interesting.
Excellent. Yeah. Do you have a DevSecOps background or a project that you're working on, or Kubernetes at
all? Yeah, I was chief engineer for a company and in charge of building their entire DevSecOps infrastructure. So we use AWS and a bunch of like the Atlassian tools and stuff. So I'm familiar with it, but I haven't used Elastic, so it's kind of an interesting way to look at it.
Awesome. Well, it's kind of a dense topic, to be honest with you. It's a lot of folks, especially in DoD. So Joe joined us. I think she dropped back off. But we started up a co-op of interested folks from the DoD space, the vendor space, and then also some of the kind of consultant space, where we were finding that folks did not know really what DevSecOps was. We would get questions like, what's a container? Why do I care about this? So I actually put this presentation together for that purpose. If anybody's been to a recent, I've actually given this a couple times, so I apologize. I'm going to try to break it up a little bit and allow folks to ask questions at various points. So if you sat through this before, I'm going to try to interject and get more audience interaction, but let's get started. So way back in the dawn of time, before the internet, if you were into computing at all, you were probably a developer of some sort. Back then, the systems were not built to talk to other computers. You just built your software to run on your platform and only work on the data that you fed it, right? As the software ecosystem and the tools got more complex, so did the ecosystem in terms of how software is made, where it runs, how it's protected, and what it can affect if it goes bad. So we began to see the need for additional expertise in the form of the operations that are necessary to run the infrastructure, the networking, all the complexities that your developers rely on. Over the years, operations developed a set of tools that let them manage that infrastructure in a reliable way. And eventually, the tools of developers and operations began to merge so that you have basically they called it DevOps, right? So it's a buzzword to keep track of. Separately, security were working on their own set of tools, but those mostly stayed around the edges of compliance and risk management. It wasn't really built to interact with anything else. But as is usually the case, if you don't build security in early to the process, eventually down the road you find that you have to back up a few steps because there's something up the chain that will break because you didn't include security into your development process. So that basically led to the development of a new Uber buzzword, DevSecOps. And now it's really just three words that are smashed together. So what does that really mean? Well, you may have seen the infinity symbol used for DevOps or DevSecOps. What that's trying to convey is the idea of a continuous successive phase of continuum, where each phase will support the previous phase, and that enables the next phase. So when you get to the end of one cycle, you start another one with the insights that you gained from that previous cycle. Behind the scenes, DevSecOps relies on agile methodologies, which are based on short targeted sprints of development with a philosophy of fail fast and iterate. Most development teams today are kind of used to the old way of doing things, where you have a waterfall approach where you're not really, every step is interlocked with the previous step, and you're not done with the project until every single part of that checklist is done. With Agile, you break up those tasks into kind of more bite-sized chunks, and you attack each in short sprints, and you learn by failing and adapting as you go along. That's why it's called agile. Agile teams can basically apply that methodology to the continuum so that you have a workflow. Basically, it creates the ability to automate your build, test, and deployment processes. It reduces your drift between the different deployments because you have standardized configurations. You reduce your attack surface because you're using pre-hardened components that you are like known quantities of for each of the different kind of components of the infrastructure. And then you get out of that process, you get ruggedness and resilience and the ability to fail fast and with loosely coupled components that won't break down the whole system when they fail. So obviously, this is more than just kind of a technical problem to solve. There's also other aspects to it in the form of the people, process, and technologies have to work together, basically. So in addition to developers, you have operations and security teams that have to adopt these principles as well. There's a huge culture shift that's involved in that most people don't feel very comfortable embracing failure. It's a mindset that people are just not comfortable with. And there's a term called psychological safety, where your mistakes are used to make everyone better. But it's very hard to get folks to buy into that. I know myself. I've come to a lot of, whenever I come into a new situation, you're trying to prove your worth, and you don't want to look like you're making mistakes, but in this world, it's actually supposed to be a benefit. You're supposed to take mistakes, learn from them very fast, and help everyone get through it. The supporting processes also have to take advantage of this mindset. So your management processes have to be designed around long-term delivery timeframes. They're typically around long-term development instead of the short kind of sprints that are involved. And then you have management. Like DoD has a leg up on this from the perspective of they're used to a decentralized management where you give somebody a task and they go out and perform it. You don't actually have to go and tell them every step of the way to get it done. That actually plays very well into the DevSecops mentality. So the processes also have to, be adapted. So you have, in one sense, DevSecops is very much a merger of DevOps and SecOps, where you have continuous testing and scanning of your processes, and that gets broken down into individual steps. That also means that your organizational processes for doing everything that are related to it have to adapt at the same intervals in order for them to keep pace. And so it really takes a very concentrated effort to get all those different teams aligned to why this is a good thing. The hard thing about this is that if they're not aligned and the folks are not all kind of rowing the same direction, you get breakdowns where you have the technology is constantly changing and improving. The threats do as well, and that's usually where the enemy or your processes will tend to break down. Enemies will slip in there and try to break into that complex environment. When you combine it all together, you get building blocks of hardened containers that can be built on demand in best practice configurations with baked-in security, and that helps you to adapt to things like zero trust environments, and chaos engineering gets baked into it as well. So I'm going to take some liberties here. So I apologize for the corny jokes, but the end result is more than sum of its parts. It is infinity indeed. So DevSecOps provides a lot of upsides, obviously, and even the DoD, who's not known for being very agile, has taken notice. Everything in DoD has to have an acronym. It's the law. So the DoD, the DSOP is the DoD Enterprise DevSecOps Initiative. It's a joint effort of the DoD CIO's office, the Undersecretary of Defense for Acquisition, and the individual DoD service branches. It's being managed by the Chief Software Officer of the Air Force. His name is Nick Shalan. Very forceful personality. He's gotten a lot done in a very short time, and I'm actually very. I'm actually a former Army soldier, 10 years active duty, and I've been working in the space for quite a while, and I'm very pleasantly surprised by the amount of progress that's been made in the time that this program has been going. I really think it's going to be a benefit to not only DoD but the country and the world in some form or fashion. So one of the cool key features of this program is they've taken the benefits of having a well-documented, very kind of known quantity in the environment that they've stood up for what gets deployed, how it gets monitored, and how often it gets kind of scanned, and applied that to the acquisition process. So they've got BOAs, blanket ordering agreements, that basically let folks that are trying to make purchases of the software or the components involved in standing up a DSOP stack, they say, look, these are constantly being scanned. We don't have to go through this long process up front to validate that the software is ready to deploy and authorize on our networks. Someone's already done that for us. So they've taken that approach to the acquisition process, and it's helped things a lot. I'm going to pause in a minute for questions, just in a second. So are those changes worth it? Well, according to DoD, they are worth it. So they allow the DoD to save money. They're able to be more flexible about how and where it deploys. They can build in the extra security and automated testing. And having those capabilities, again, speeds up their authority to operate. It establishes trust in the evaluation chain, so you can move beyond the kind of natural old approved products list where everything gets kind of certified on every possible permutation of a deployment platform, and you have a system in its entirety that's able to be kind of deployed together. Adds up to a more fast and secure environment, and it allows the DoD to keep pace with the adversaries as well. So this is kind of an overview of the platform. May not be of interest to some of the folks here. This is just kind of describing exactly kind of the process of Elastic as a vendor pushes code that's already been kind of pre-approved using the Red Hat base and universal base image. We build our products onto it. We have a specific distribution chain that goes into repo one for scanning, continuous scanning and hardening. And then once it's approved and gets through all the checks, it goes in Iron Bank for use by any of the consumers in that environment, whether that's through Cloud One, their hosted service, or through they provide through their Big Bang value stream. You can have your own platform one at home, basically, where it would be on-prem. I'll pause there and see if there's any questions so far. There's a lot of material I just kind of skimmed through. Anyone?
So in this diagram, the colored sections are, this looks like just a platform one kind of thing. Are you showing any Elastic pieces in here?
Not yet. Yeah, we didn't get there yet. Sorry. I was just trying to give a kind of an overview of, because this was about platform one also, I wanted to show, kind of give a background for what is the background of platform one. But we're going to next. Any other questions before I move on?
Are we going to get the slide deck later or no?
Yeah, we can send it out to you. Sure.
And just to note that this is being recorded. So, and typically what we do is we put the recordings up on our community YouTube channel, which I linked in the chat. So you can check it out again there. And yeah, we can also add in the slide deck as well.
Cool. All right, so we've got all our building blocks in place. We've got all our people. They're armed with new ways of doing things. The processes are all agilized and sprinty. We've got our marketplace stood up. We're ready for DevSecOps, right? How do we know? How do we know what's happening in our environment, whether everything's functioning as we expected it to? How do we begin to measure all the different pieces of this environment to figure out whether things are working the way we want? Well, the answer is observability. You have to monitor all the different data points so that you can track and keep track of all those things as they occur. And you can't measure success without monitoring the key indicators that mark it. So how do we begin to monitor all the things? Well, it'd be really cool if we had a spider sense that would allow you to detect events as they're happening, but I think that would get overwhelming pretty quickly. What most organizations have done instead is they deploy a myriad of different tools to measure different bits and pieces. Each has a distinct view. None of them are connected to the others. And what you end up with is something like this, where you have multiple screens observing different things. You have some tools that measure your logs, other tools that measure metrics and graphs or KPIs, other tools to measure the system availability, some niche tools to do things like network or cloud metadata. So it's not a stretch at all to say that this is a very fragmented landscape. So how big of a problem is this? Well, if it's not just a single system we're talking about here. We're talking about multiple layers of multiple things that we have to monitor. So we have hosting environments that are being monitored, the compute platforms that sit on top of those, the operating systems, the services and the applications running on those, and the data that's moving through them. And from each of these layers, we may have a bunch of different things we want to capture. So there's a variety of different data streams generated at each of these layers, and it's important to capture as many of them as possible. First of all, that's the components that build up your KPIs and let you see what's going on in your environment. But also, if you're missing any telemetry from any of these, that could be a blind spot in your ability to troubleshoot issues or maybe even affect your security posture. My personal definition of observability, I know it's a buzzword, but my personal definition is the ability to capture events and logs from all these layers, measure the impact of those events using metrics, and then using telemetry to identify the root cause. Once you've done that, if you keep a longer tail of data, you can begin to proactively investigate those events and prevent them from recurring in the future by doing pattern recognition and trends analysis. So let's pick a line from a DevSecops perspective through these. We'll choose the host in the cloud. Any cloud would work, of course, but for this example, we'll use AWS. We're definitely using orchestration in the form of Kubernetes and maybe some supporting tools like Istio. Within Kubernetes, we'll be spinning up and down pods of containers of all sizes. Those containers will house applications that provide access to data. We're going to go with Kafka for this example. And of course, the data going through it is your own data. So from each of these layers, you're going to capture different things. AWS exposes different things, everything from the logs that are from each EC2 instance to CloudWatch to VPC flows and even things like billing. From the containers perspective, you want to capture the nodes and metadata from the containers, the events that are happening in the environment, the images on those as well. You're going to want to capture the metadata about those events. Kafka is probably not a great example here for the data, but it's, you might want to do analytics on exactly, who's accessing what data, how fast your different queues are within that application and that sort of thing. A lot of different data here. So that's a lot of things to monitor. How do we do all that and make sure that there's not a problem buried somewhere in these myriad of different systems? Well, the only way we can avoid that swivel chair hell that we saw earlier is to bring it all into a common data access layer like Elastic. So once it's all in this common data layer, you're able to bring it in through what we call Elastic Common Schema so that it's all speaking the same language. And once it's there, you have access to all the features of Elastic Stack, including cross-cluster search, cross-cluster replication, machine learning, visualizations, dashboards, alerting on all that data. And then once you have all that in that common data access layer, you can use it not only for Kibana, which is our visualization tool into the stack, but also because we're API first, you can support any of the other applications out there in the world that are within your environment that need access to any of your data. So it suddenly makes those applications that were meant to work with one data source multifunctional in that they can access all the data relevant to their application. They don't have to have, purpose-built, very specific integrations that you have to keep maintaining. If everything is accessing the same data source, you have one source of truth. So quickly go over the Elastic Stack. Core part of the engine is Elasticsearch. That's the engine that stores and provides search results to your queries. Beats and Logstash are part of the ingestion layer. So Beats are lightweight agents that sit at or near the edge of the network, collect data on specific protocols, files, metrics, network flows, event logs, and that sort of thing. Logstash is an ETL tool, so Beats can push either directly to Elasticsearch or through Logstash if you need to do some heavier load, type, extract, transform, and load operations. The cool thing about Logstash is it has inputs for multiple different sources. So while Beats is more of like a push modality, Logstash is a pull. It can reach into databases or file systems, pull data in, chop it up, put it back together the way you want it to be done through ETL, and push it directly to Elasticsearch or simultaneously to other data sources as well, things like Hadoop or S3 or other SQL databases if you wanted to. And then Kibana is your window into the stack. That's where we host most of our solutions are stored in Kibana, along with the management layers. So those solutions are kind of break down into 3 buckets. We have enterprise search. Obviously, Elastic is a search engine at heart, so that's where that's really where we started. Observability, I gave you that definition earlier. That consists of the logs, metrics, APM, which is application for performance monitoring, and heartbeat based uptime is the application in there. And then Elastic Security. So Elastic as a general purpose stack has been used for security for quite a while now. We began creating our own SIM app just around 2 years ago, and it's really kind of it's amazing to see the progress that's happened. We also acquired a company called Endgame, which had a Elastic-based endpoint security tool. If anybody has any questions about that, more than happy to answer some questions after the fact. But that's kind of the way that the solutions that are built on the stack that Elastic provides breaks down. Those are the flavors of them. We don't force you. The cool thing about Elastic is we don't force you into any one of these buckets. If you come to the stack with a observability question, how well are my servers running? And you see something in the logs that looks a little fishy. If you are of the mindset and have the capability of the security clearance, the RBAC controls to access it, you can immediately pivot over into the security app and begin triaging that event through timeline, and then pass it off to a third-party system through our cases integration or to a SOAR integration. Really very flexible. We don't force you to shoehorn your data into one viewpoint. You can use whatever viewpoint you bring to the stack. And then we let you deploy the stack any way you really want to. Anybody can go to the website, download the software, and immediately start up a cluster and start ingesting data within a few clicks. On the fully turnkey end of the spectrum, we have Elastic Cloud. That's a hosted service that we manage for you. Lets you point and click and create clusters and do upgrades in place and everything right there in a UI-driven experience. We've taken that expertise that we've developed in the same software actually that we developed for our hosted Elastic Cloud service, and we packaged it up as a offering called Elastic Cloud Enterprise that you can bring to your own environment. So if you wanted to get out of the business of managing Elastic Stack manually, you can use Elastic Cloud Enterprise. Or if you're in the Kubernetes space, you can use Elastic Cloud on Kubernetes, which is our official operator. Doesn't have a UI yet, but that's, if you're in that space, that's probably the way you would want to use it. I'll pause there again, see if there's any questions, and I'd like to take a drink of water. Got a cold coming on.
Hey Woody, it's Alex again. I have a lot of questions, so I don't want to usurp all the time. If you'd rather I type them up, I can. But I had a question about correlation. So I imagine that there's some sort of pieces of data coming out of all these systems that could be correlated. Is that something that your Kibana layer does? Do you focus on any kind of correlation of data?
Alex, I swear you're teeing me up perfectly. So the next topic is Elastic Common Schema. Elastic Common Schema is an open source standard that Elastic has hosted. It was really meant to help you normalize data from all those different data sources. So when you're ingesting data using beats from multiple different systems, you don't have to have a mapping or manually create a mapping that would bring that data together. You can use the beat will understand the data stream it's ingesting, automatically put it into Elastic Common Schema format so that it's usable everywhere. That not only makes searching for it easy, it also allows the analytics and the solutions that are based in Kibana, lets them work on the data the same way. So again, you don't have to know that client IP is in one system is equivalent to IP address on another system or another detector or another tool, what have you, wherever you're collecting your data from. It just works. It's all host IP in that case. So you can do queries against your local cluster. You can do queries against your local cluster and a remote cluster, and you can do analytics, machine learning jobs that will span your entire infrastructure all in one spot. That answer your question, or do you have any follow-ups? Or
yeah, no, that's pretty much what I was wondering about. So
we're on the same page. That's great. I'm glad it makes sense. So take that concept a little further, if anybody's familiar with kind of the 5 domains of airspace, land, and sea, and then cyber being the only one that humans can control. Anybody's read I've got a book behind me, The Fifth Domain. It's a great book. I highly recommend it. But there's common areas of data across each of these, right? You have some of them are going to have infrastructure. Some of them all of them going to have infrastructure. Some are going to have strategic. Some are going to have tactical. I'm speaking from a DoD sense. I apologize if it doesn't translate directly. But you might have departments within your organization that have common types of data that you need to have access to. With Elastic and the distribution capabilities, you can create a cluster that would span each of those domains from the domain perspective. So you get all the data from air in one cluster, in one viewpoint through cross-cluster operations, or all the way from sea, or all the way from cyber, right? You can also create dynamic clusters. Well, first of all, you can create a Uber cluster that spans all of them. So what I've turned a global data mesh, right, that basically lets data live wherever it's closest to that original data source, but you can still access it from successively higher levels. But then you can also create, with cross-cluster replication and role-based and attribute-based access controls, you can create dynamic views of that data as well. So you can have a user role that has access to all the cyber and all the tactical from each of these domains if you wanted to. If you have an investigator that needs to have access to specific host information, you just give them access to that through role-based access policy, and they immediately have access to the data that's relevant to their mission, to what they're trying to accomplish. Very flexible. It allows a lot of kind of new ways of exploring data. If it's all in the same place and it's all in the same platform and it all has the same security controls on it, and it's a common way of accessing it, it makes it very, very easy to kind of make this a reality. This is actually something that in my career, I've been working on for quite a while, trying to make a reality, and Elastic's really made it happen. I'm gonna pause there one more time for questions before we move on to the next section. Okay, cool. So let's bring that back now to the DevSecops Continuum. So the ability to have that level of observability across all the different aspects of your environment, the applications, the platform itself, applying that to the cycles of the DevSecOps Continuum, you can, at the plan phase, take the planning feedback from previous loops to codify and inform the decisions you make to do in the development phase. The code updates that you are tracking are used. You can use to verify that builds are happening properly, that the proper security controls are being applied at each step. We can track the ability of, the activity of the users in the system to figure out whether, unauthorized folks are accessing parts of the cycle that we don't want to, or whether or not builds are happening and being deployed properly. Are there any containers that are not being used in this environment, or which ones are most used in this environment? What that might look like from a ConOps perspective. As a vendor, I'm pushing containers into the software factory. I can use monitoring to check whether or not they're succeeding, and I can see, what the failures are, what the issues that were found were. From the other perspective, I can say, which vendors are not responding to the security violations that we're noting in the scans that we're submitting. If you're pushing in pods or other types of artifacts into the system, same thing. You can check to see whether they're making it in there, whether they're being used by the consumers of the system. As they go through the hardening pipelines, we can track the logs of those systems as well. We can say, hey, look, are these things making it to the marketplace? Are they being used by folks in the marketplace? We can monitor the catalog usage. We can monitor the infrastructure that all this rides on, and then create the ability for anybody in this system to see it from wherever they are for their purposes of of how they want to interact with the data. The same data is useful for both observability as well as security in a lot of cases. It really depends on the mindset that you're bringing to the application. And then again, I'll pause real quick for any questions. One side note, I had one of my customers was asking about, where you might want to interject other places that you would add to these monitoring capabilities. The example they use, they wanted to do large scale AI jobs. So part of their building process was to instead of template pipelines or pod templates they're bringing in here, maybe they're bringing in different types of machine learning algorithms to bring to bear on the data sets that they're trying to test and build. You can check as part of your hardening build test pipeline, you could run those machine learning jobs against gold standard data sets, right? Get the analytics about, the latest release of that machine learning job gets these statistics, this set of statistics and metrics on that gold standard data set, so that when it goes into the marketplace, the folks that are trying to use that, combinations of those machine learning jobs, they know which one functions the best for their particular, maybe they don't care so much about the speed of it, they care more about the accuracy of it. There's that's always that continuum there where folks are trying to figure out the best accuracy for speed, and it's very difficult. That's a very difficult space to be in, actually. I don't envy them at all. Okay, any questions there? Cool. All right, so what we went over today, we tried to go over what DevSecOps is, how it came about, what some of the benefits and challenges are for the people, process, and technology. We had an overview of what the DoD DSOP program is, and we also hopefully learned about the importance that monitoring all levels of that plays into it, into why you should be monitoring everything in this environment. Observability over this environment is what lets you measure each phase and lets you know that things are working the way you're supposed to. When you bring all that together with the Elastic Stack, I think it really gives you the full picture, and now you're ready for DevSecOps.
Nice.
I mean,
yeah.
No.
Little
you got to keep yourself. Yeah, you got to keep yourself occupied when you're doing these things.
So I have two questions. Actually, Brian in chat brought up a good one that I wouldn't mind the answer to as well. It's
okay.
Is there a document describing all of Elastic Common Schema? And then my extension to that is, are there ways so there's a common schema, but are there ways to redefine or define new correlation, new analytics of the data that may be specific for certain jobs?
New analytics, could you explain that a little more while I pull up the Elastic Common Schema documentation?
Oh, okay, so I'm assuming that there had to have been some analysis of standardized log data that you guys are going to do a correlation on. Like you brought up the example of IP, but what if there's non-standard data items that are coming out of some of our systems? You kind of mentioned machine learning algorithms, right? So data sets. What if can you compare the differences in data sets that aren't captured in your common schema? Can you extend a schema or create your own personal schema to do that? Yeah,
so it's actually so Elastic Common Schema is an open standard. Actually, commonly, I literally just got a phone call talking about this exact thing. Let me move this out of the way. So let me make this a little bit bigger too. Sorry. So yeah, Elastic Common Schema, it starts off with, it's kind of built to span the different types of data from, it's built to be the kind of the connective tissue between the different detection and like data generating tools that span the enterprise. So, you have systems that generate host information that they need to be mapped together. So you need to know what an IP field is, that the same IP is used for a host here is used for a destination here, or, that sort of thing, being able to correlate that. There's a few gaps in here, and I feel like more and more, that's kind of the work these days of bringing this together and fleshing it out. I find a lot of times that, especially for specific data streams, you'll get 60 to 80% coverage with the ECS fields, like the baseline ECS fields, and then you'll have to extend them. Like I found myself extending this was a software-defined perimeter tool for one of my customers the other day, and they were getting fields in that data stream that were things like session information. That's not covered anywhere in the schema. So I had to extend the, I think I extended the network fields for, and so, network dot session dot whatever. Obviously not part of the official schema, but they still want to capture that data, and it's related to the network traffic. So the good thing is, one, it's an open standard that everybody can participate and contribute to, and it makes it better for everybody. But secondarily, if you kind of use that way of extending it, you can actually, it's a lot easier to kind of remap. So if, say, a couple of releases down the line, they create a session object at the top level, it's easy to kind of remap that using field aliases, for instance. I hope I answered your question there. I tried.
Yeah, no.
I have a tendency to ramble sometimes. Someone's got to stop me.
No, it's perfect. And I sound smarter if I keep asking questions from the chat. So I'm going to ask another one. Okay. Kathy asking about, can you migrate existing stuff from Splunk to Elastic, dashboards, monitors, alerts, and stuff like that? That's something.
Can you migrate them?
From Splunk to Elastic, yeah.
We have some, so there are some tools out there that let you do migrations. We probably would have to investigate exactly what data you wanted to migrate and like for what use case. But there are definitely some tools out there, and the difference. A lot of people, that's kind of one of the first questions they ask, like, oh, so you're sort of like Splunk. Well, yeah, but we're faster, more nimble, and like I said earlier, we don't force you to kind of use the viewpoint of everything as a SIM problem, right? And technically speaking, Splunk's not really a SIM either, if you go back to kind of the formal definition of it, but they've positioned themselves as a tool for that space. The problem with it is, Splunk can't really, no one can afford to keep their data in Splunk for the security use case, the real-time security use case, unless you know up front what you're looking for, which no one does. If you ever have to pivot and you didn't account for that field in your schema, yeah, they have what they call schema on read, so they can modify that schema and go get it. But that, again, kind of, you have to wait for that query to rebuild, to rebuild the index for you. So the more data you have, the bigger of a problem that becomes. Did I answer your question, Kathy? I probably didn't. Something about, I'd have to, I'm more than happy to jump in and investigate that some other place.
I have another question about how this relates back to DevSecops. So sure. We talked about it being a monitor for the processes and things. Is there does this have some sort of plugin or ways to feed back into the process so you have an automatic ATO process going on? And I imagine some of those, I'm not sure exactly how Platform One and Cloud One work with regard to that, but I imagine there could be some shortcutting. Something doesn't pass. We want to stop the process and either auto create a ticket, auto create an alert, say this isn't passing. We don't do any more work as far as the scanning and stuff because you hit a critical issue. Does it have any kind of loop back into that where you can not just monitor it, but also kind of have that feedback loop to say, stop the process, the CI/CD process, and create a ticket, or you know what I mean? Like how integrated is it with those tools?
That's actually very close to what we're doing at DSOC for Platform One. So we're integrating with not only integrating from the vendor perspective. So we are tying our release schedule directly into their pipeline. So when we release a new version, which is like every 8 to 10 weeks with last, our minors are majors, as we like to say. But that automatically gets built and then pushed into their pipelines for scanning and hardening. Once it gets approved, it's continuously scanned on the other side. So that process, we're going through that process from a vendor perspective on one standpoint. We're also building the monitoring on their side to tell you, hey, these are the this is the status of all those different operations inside of your environment. So not only are we monitoring the infrastructure that it's running on, the Kubernetes environment, the Docker containers that are running in there, and also the applications and other systems that are running as well. So we're literally bringing all that together into one place. So you can, and then we're API first, so it's very easy to kind of take something that happens in one place, one part of your environment, just fire an alert on it that then feeds into an API call to either internally to kick off another process internally. Maybe it goes directly into a timeline or a case that goes into your case management system, or automatically pushes me. I've seen systems that will automatically, depending on the severity of the issue, obviously, they will turn a port off in the firewall. They'll actually tie into the Palo Alto firewall and say, hey, that behavior is absolutely never allowed. Do that for me automatically, without even use of a SOAR.